batteries and a dehumidifier that turns humidity into water. And the walls are insulating also. So I'll begin by the structure of the shelter. So the walls of the shelter are made of 3 layers. So as you can see, there's 2 thermal insulating plastic layers, and in between there's an expanded polystyrene board. You may ask why we put just expanded polystyrene in without the plastic. Well, the expanded polystyrene cannot hold itself alone. It has to have a plastic covering it, and it's for more insulation. So I'll give you 2 examples of heat transfer coefficient. There is this is the heat transfer coefficient for the polystyrene, which is 0.03 watts per meter squared per Kelvin. And the copper is 398 watts per meter square Kelvin. I know you would be thinking we wouldn't use copper, but it's just a comparison. What's heat transfer coefficient is? It's the amount of heat that could be transferred through a material. The lower it is, the lower the heat it transfers, and the higher it is, the more it transfers heat. So by having low heat transfer coefficient, we have insulating walls, which will keep the temperature of the outside from the inside. Okay, now I'll go to power production. I'll be talking about solar panels. What are solar panels? Solar panels are they provide us with free and green energy. They convert light into direct current, electricity, which will power the batteries in our shelter. I'll explain how solar panels work. First of all, I'll explain how they're made. The most common material in the semiconductors and the solar panels are silicon. So, but we cannot just put silicon in the solar panel. That's why we have to dope them. What is doping? Doping is when you put impurity into you put impurity into an atom. So you modulate its electric properties. First of all, we'll see how the positive atom is made. We add to the silicon the boron atom, which has 3 electrons, and at the end we get a silicon atom with 7 electrons, which where we will have 1 less electron, which makes it positive. And then for the negative layer, we add the phosphorus atom, which has 5 electrons. And by adding 5 electrons to the 4 electrons in the silicon, we have 8 electrons on the silicon atom and 1 electron in excess, which makes it negative. When we add these 2 layers together, we'll get, as soon as we add them, the electrons from the N-type will move to the P-type, because there's in the N-type, as we said before, there's one extra electron in the layer, and in the P-type there's 1 less electron. So the electrons will move from the P-type to the N-type, and the P-N junction will be formed. It's a barrier that no electron can move without enough energy. So the P-type layer becomes negatively charged, and the N-type layer becomes positively charged. Okay, now we'll talk about the light power. What happens when the light enters the solar panels? Light have something called photons. Photons are light atoms, you can call them. When a photon enters the cell, the semiconductor, like the solar cell, it gives enough energy to 1 electron to break through the barrier and go to the N-type layer, and it goes again and again. But when an electron leaves the P-type layer, it becomes unstable, so it has to go back again. And the path with least resistivity is the wire because it has, the energy is gone and cannot go back through the barrier. That's why it goes through the wire. And when we have electrons circulating between the p-type and the n-type through the wires, we'll have an electric current. I'll just let you watch this video to explain more.
Packets of energy called photons. Every minute, enough of this energy reaches the Earth to meet the world's energy demand for a whole year. Photovoltaic panels consist of many solar cells. These are made of materials like silicon, one of the most common elements on Earth. The individual cell is designed with a positive and a negative layer to create an electric field, just like in a battery. As photons are absorbed in the cell, their energy causes electrons to become free. The electrons move toward the bottom of the cell and exit through the connecting wire. This flow of electrons is what we call electricity. By combining solar cells and photovoltaic panels, we can produce just the right amount of electricity to perform a specific job, no matter how large or small.
Okay guys, I'll leave you with Shadi to explain more about power production and how the electricity from the solar panels will be used in our shop. Shadi.
So in our power production, we still have the battery component and the capacitors component. I'll first explain how the battery components works inside our shelf. So battery is basically simply made of three basic parts: a positive and a negative electrode, and an electrolyte that moves the positive ions and negative ions between both of them. Batteries produce electricity by electron transfer from the negative electrode, which has an excess of electron, to the positive electron, which is lacking electrons. In order to understand this, we have to understand Coulomb force. Coulomb force is simply discusses that different charges act differently together. Positive and negative charges will attract each other, and positive, if the same charge has the same sign, if it's positive and positive, it will repel. So that's why electron transfer works in the battery, because the negative charges are attracted to the positive, and the transfer of electrons from the negative electrode to the positive electrode is what produces the electricity. Now, since both of the electrodes initially have a constant amount of ions or electrons and protons in them, more ions need to be produced on both electrodes for the reaction and transfer of electrons to continue. That is done by using the electrolyte. That is done using a reaction called a redox reaction, where each of the electrodes of the battery either lose or gain ions. Now, an example of redox reaction is a copper-zinc battery. Both electrode, the zinc electrode and the copper electrode, are submerged in a salt solution. This salt solution reacts with both the electrode differently. The salt solution would react with the zinc electrode by losing its electrons. These electrons are which produce the excess of electron on the zinc. It also reacts with the copper electrode, making it lacking some electrons. These electrons are then going to be transferred through the load, producing electricity, and the reaction continues until there isn't any possibility of gain or loss of electrons between these two electrodes. That's simply how a battery works. Now I'll move to the capacitors. Capacitors are simply made of two initial parts. Two oppositely charged plates produce an electric field due to different charge between them. Since capacitors have charge on them, it is able to store it. Any conductor that carries charge is characterized by an electric potential. This electric potential is the reason why capacitors are able to store electric charge, thus storing energy. Now, now this concludes our power production inside our shelter. I'll just give a quick review. Inside our shelter, the solar panels are going to be responsible for producing the electricity. And then this electricity will be transferred to the capacitors, which will charge and recharge the batteries that we have in our shelter, and thus producing the necessary electricity for the lights and for the dehumidifier. Now I'll leave you, Fadi, to explain more about the dehumidifier.
Okay, so I'm going to be talking about the humidity, water condensation, and why we choose to have a dehumidifier in our system. First of all, I'm going to start off by talking about the molecular structure of water and its gas and liquid phases. In the gas phase, the water particles are far away from each other due to the high energy that each particle possesses. The high energy causes the particles to bounce off each other rapidly, which causes their constant separation. That's why we can't see the water vapor in the air, because the water molecules are far away from each other. In the liquid phase, on the other hand, the water molecules have less energy, and therefore they pack more closely together, which gives them liquid characteristics. Taking all that into consideration, what is water condensation? Water condensation is the process by which water transitions from its gas phase into its liquid phase. How does that work? Well, basically, condensation works by cooling the water molecules in the gas phase. As the molecules are cooled, their temperature decreases. Now, decreasing temperature means that heat is removed. And heat being a form of energy, it also means that energy is removed. Now, as I talked about earlier, lower energy means a more tightly packed water molecule system. So, as the gas molecules are cooled, they gradually start packing closer to each other, and therefore, gas water gradually starts transforming into liquid water. As for humidity, it's basically the measure of the amount of water vapor in the air at a given temperature. Now, the reason I'm talking about humidity is because of the negative effects that high humidity has on the human body. Now, humans are very sensitive to high humidity because the body always attempts to maintain an optimum temperature through sweating and the evaporation of sweat into the air. Now, when we have high humidity, the air is almost saturated with water vapor, and therefore it can't take any more. So it's harder for sweat to evaporate. So it stays on the body, it makes the body warmer, which leads to dehydration, trouble sleeping. Now, if you look at this picture and notice the date, it's March 29, so that's yesterday, and it's basically a weather forecast showing the percentage of humidity in South Africa. If you notice in Cape Town, it's 100%, in Johannesburg, it's 94%. Now, that's very high. And considering a country where humidity can be this high, we found that putting a dehumidifier is essential. And the reason I talked about humidity and water condensation is because they're the main concepts behind the functioning of the dehumidifier. Now, the dehumidifier basically sucks in the humid air, condenses the water vapor in it into liquid water, which is collected in a separable bucket, and then the dry air is pushed out the other side. By doing this, the dehumidifier reduces the amount of humidity, and therefore reduces the negative effects that humidity has, and therefore provides a more suitable living environment inside the shelter. Okay, so this basically wraps up our presentation. Now we'll take questions. We'll be glad to answer.
Okay, I don't really get about the capacitor. So like, where is it? Is it in?
We're gonna have basically multiple capacitors inside the shelter. Capacitors are really small, so we couldn't even show it on that diagram. But it's gonna be like small wires running through the entire shelter, storing energy. Any further questions?
Did you guys decide if it was going to be like for a hospital or something?
We thought about that. It would actually be a good idea. Yeah.
Like, is it for a house?
Well, it can be both. Natural disasters, anything.
Yeah.
Because it's pure environment inside and it's thermal insulating. So.
But like, how many of these shelters can you provide for these people if it's that expensive? Like,
It's
I
not
like that's from your last.
It's not expensive, it's a one-time cost.
It's not expensive.
No, capacitors don't cost that much. Neither
No,
do
not
they.
the capacitor, the whole shelter, the
Yeah.
whole package. I mean.
It's a one-time cost, even if it's cost a bit more, but it's a
No, I
one-time
think the
cost.
most
for-
expensive thing about the shelter would be the insulation material. That's just like
Okay, compare this to water transportation.